There are a few changes for the new MOSFET switchboard. Electrically, I've added a little more filtering to the supply lines for the MOSFET driver. And the MOSFET driver is now the B version. That changes the input reference to VDD and ground instead of logic level inputs. So this will have more noise immunity. The biggest change though, the power transistors are now IRF40 SC240s. I was very pleased with the IRFS 7430s I was using, but the 7-pin version of it are just too hard to get hold of, so that's the reason for changing MOSFETs. It may work out well. The SC240s are a little beefier than the 7430s, so I'm going to try and get away with just 4 per board. Of course, with the change of MOSFETs, I've had to find new values for the turn on and off resistors, but I want to increase the turn on time a bit anyway, so with a 301 ohm turn on resistor, it may be increased 10% or so. I took the turn off resistor values down till I started to get a bit of ringing at turn off. That ended up being 2K ohms. If I end up blowing a clamp diode, I'll have to increase those resistors a little. Mechanically, the board is now less than 4 inches long, making it easy to mount beside the capacitors. The green here is the bottom copper. Red is the top copper. Vias connecting the two. The purple here is the exposed solder mask area for the top copper. The high current connections of the board will be made with thin copper connectors, one soldered to this top connection and one soldered to this bottom connection. The PC board to copper bar connection will be made with some 0.01 inch thick, 1 inch wide, and 3 inch long copper sheet. The scrap I have is old and beaten up, so I'll have to fix that. I don't have smooth jaws for the vise, so I'll just pound them with a hammer till they are flat enough. Then scrubbing the oxidation off with a Scotch-Brite pad till I think they will be solderable. I'm using an 1/8 inch thick and 1/2 inch wide bar as a form to bend the copper sheet. To keep the sheet aligned on the bar, I'm taping it in place. The first try into the vise was not taped, and unfortunately the cursing started before I thought of taping it. I'm bending it into a J-shaped channel. The short leg, about 3/8 inch in width, will be soldered to the PC board. The long leg, a 1/2 inch in width, will get soldered to 1/16 inch thick copper bar. After bending, I'm straight off going to tin the two surfaces that will be soldered. This alligator clip holder works well as it doesn't sink a lot of heat away. The inside edge is a little harder, but if the copper is clean enough and with plenty of flux, the solder flows quite well. I'm using solder wick to remove any puddles or high spots of solder, as I want the copper to lay very flat on the PC board and bus bar. After having assembled a few of these boards, I think I have found the least thermally traumatic order of assembly. With just 1 ounce copper on the boards, I've made the space between the copper connector and the transistors very tight, so it makes it very hard to solder the tab of the MOSFET if the connector is in place. So step 1. Solder the MOSFET power transistors to the PC board. I'm using as big a tip as I can for the leads. There are of course no thermal reliefs for any of the MOSFET terminals, so it takes a bit of heat to solder to these solid areas of copper. For the tabs, I moved to the biggest tip I have. This is why it was a problem to solder the MOSFETs after the connector was in place. Step 2. Solder the copper connectors in place. I'll put a good coating of flux on the surfaces, then clamp the connector in place. I don't want it to move on me. I doubt I could remove it without damaging the PC board. Then I need to make sure the distance is right. From inside of one connector to the inside of the other connector needs to be less than 0.8 inches. I'll tack solder each end so I can remove the clamps. Then just throw the heat and solder at it. I did find it is a good idea to clean the flux off the copper pretty fast. It will leave quite a green stain on it. Next, just the tediousness of soldering all the other little parts. Well, the first one wasn't tedious, but now at number 4, it is. It might be a little better to put these parts on after the copper bars are soldered to the connectors, but it didn't appear that the PC board got that hot when soldering the bars, and it is quite a bit easier to put these parts on without the bars sticking out from the board. And the last step, soldering the copper bars to the connectors. When mounting the bars in the holder, it helps to mount them as far out from the aluminum block as possible. Turns out 1/2" aluminum is quite a good heatsink. I thought of a holder out of hardwood. It would have been less of a heatsink, but I'm not sure how well it would have held the bars when it got hot. Now before I start, I make sure there's no air moving in the room. I do a little preheat with a hot air gun, about 4 minutes worth. Then it's time to tin the bars. This is about the limit of what this soldering iron can do, and the reason I'm using this 1/16 inch bar and not 1/8 inch bar. I just didn't have enough heat to get a good solder joint on the 1/8 inch thick copper. Just placing the modules on the bars so that it looks straight. Things like the module being crooked on the bars will bother me. So I'll solder down 2 spots just to hold it in place. Then it's just a matter of heating up the copper to get the solder to flow into the joint between the connector and the bar. While I don't know how well these solder connections will do long term, I'm sure they are better than the screw connections I had on the previous boards. I knew over time the PC board would mash where the screws are, and that would make for a bad connection. So I was looking for a connecting method with no maintenance. So if these do work out okay, I'll find a place to post the schematic and board files online. Thank you for watching.